Hello, let's solve some easy lead code problems. First one is number of zero field arrays. Given an integer array num returns the number of subarrays filled with zero. A subarray is a continuous and empty array of subarrays. And we return in 6 because for occurrences of 0, 1, 2, 3, 4, yes. Two occurrences of 0, 0, yeah. And there is no occurrence of subarray with size more than 2 filled with 0, therefore we return 6. So we return 6. Okay. So so we need numbers of subarray formula. I think it's n multiplied by n plus 1 divided by 2. It's the same as the sum of elements. So the easiest way to remember it, I think it is number of subarray for me. Let's quickly check it. Yep, that's it. And so easy way to remember, we do like triangle from numbers, and we have like 1, 2, then we have 1, 2, 3, and we have 1, 2, 3, 4. You got the idea. So, and this is a 1. So of array 1, amount of subarray will be 1. If we have a 2, amount of subarray will be 3, right? If we have 3, amount of subarray will be 6. I forgot how to count to 4. Yeah, and if we have 10, right? And so on. So it's the easiest way to remember it. And so our goal will be find zero subarray and calculate the amount of this. Or we can use the same approach on counting. So we will call it, this we will call it total, and this we will call it counting. And our goal will be, as we go iterate array, we iterate array, we if we found 0, if 0 found, we are increase counting, right? And we add counting to the total. And if else, we reset counting to 0, and we return at the end of the cycle, we return total, and that will be our result. Yeah, so let's quickly implement this. If n, so we have count, and we have total, and we can use this. And if n equals 0, what we're gonna do, we're gonna increase count. And we are gonna, in this way, so as we iterate, let's go dry run. So we have our count and total. I don't really, yeah, I like this idea better because it's simpler. We can found like first 0, next 0, calculate the difference, calculate by formula, move on. And this is another solution. But with counting is like this solution with pyramid is it's less code. Okay, so count is 0 and total is 0, and we iterate. We got this one, right? So we have here count 1, total 1, we move to the next, count 2, total 3, we move to the next, count 0. See how we calculate 3 for all this 2. We move and so on. So this is how it's gonna work. And else, yeah, we have to add total plus count. And else we release count equals 0, and we return total. That's it. Yep. 88%. Okay, why is that? It's probably this comments. It's trying to like iterate through comments and generate documentation. Yeah, maybe. Okay, either way. So we solve this um, problem 74 and 50 with the comments. Okay. Add comments to note. Nah. Okay, either way, next one. Add minimum number of rungs. You're given strictly increasing integer array rungs that represent the high of rungs on a ladder. You're currently on the floor high 0 and you want to reach the last rung. You're also given an integer dist. You can only climb rung if the distance between, okay, at most distance. You are able to insert run in any positive integer height if the rank is not already there. Returns the minimum number of runs relative to climb to the last run. Yeah, so we have a ladder with ranks. Rank. Run. Is it run? I think it's run. So rank is, and we need to calculate the minimum number of runs must be added in order to climb to the last one. So we can only climb to two runs at a time. So we can reach first one. Are we on first one? Oh, okay, we are on first. Oh no, you're on the floor and you want to. You're currently on the floor and 850, right? So is okay. We will figure it out. So I can climb on 0, on 1s. I can climb on 3, 5, and 5. But after 5, I cannot climb. I can add, oh, I can add 7. I can add 8. So it's like distance divided by 2. 5 divided by 2 uh, give, give us 2, right? And therefore we can calculate the distance between previous one and next one. So um, yeah, we can assign previous to 0, we are on the floor, and then 4 um, and we also need like some kind of result. So what we're gonna do, we're gonna iterate. We're gonna iterate now runs right runs if runs if runs I minus previous more than distant, then we have a result uh, with 0. Then we add to result runs minus previous multiplied by distant. And at the end, we just return result. We have a linear complexity for all this. And yeah, let's see if it works for this one. So if we do this, we go 1, nothing, nothing, nothing. Oh, so let's call this previous will be 2, still 2. And now previous is 5. We add to result and we return result. That's it. Let's do this with another example. Yeah, it's simple. Yeah, so let's try this really quick for our main rounds. So what we're gonna do, we're gonna do this really quick. And we can do it. Runs is not defined. Runs. Yes. I is not defined. Okay, if run R R and we have to assign previous, we assign R. Yep. Wrong answer. So if it's 1 and output is 3, because we are standing on the first, distance is 1. Oh, okay. So previous is 0. And we do it in 3 by 1 and we get in 3. But the thing is, I guess I can check for special cases. If this is 0, if previous is 0, um, Let's add missing ones calculation, and if previous equals 0, we uh, we decrease by 1, and we add to result what is missing. Because technically we have a floor, right? We don't have to add floor. Okay, so here is also this is so the last one is not working. Distance to output 1. Oh, okay. Okay, so why it's not working here? Because we have 1, we have 3, and we're adding 1. But we're still adding 1. Let's read those positive number. And not equal 1. Because we cannot add 0 in this case. We still have to add something, but we cannot add 0. Uh, let's see. So we have 4, 6 is 1. I really like this calculation. I don't want to replace it with while adding, adding until we reach. So, because it's kind of like brute force-ish. So between 4 and 6, what we have here. So we add in 4 and 3, which is for 4, we need a 3. Is that correct? Because we have a 4, right? Okay, we have 1, 2, 3, 4. So we're standing on 1, we don't need 1. We add 1, we add 2, and we add 3. Oh, maybe we are not standing on 1. I think we are standing on 4. So we add 3, which is correct, right? Then we have another one on 6. So this is 4. Let's go for 6. 6. And we need to add, we have to add another 2, right? That's it. And total will be 5. Why total is 4? Oh, because we have a 6. Between 6 and 4, we have to just add 1. 4 by 6 minus 4 divided by 1 equal 2. So we're adding 2, but we have to add 1. Yeah, that 1 distance is making the whole thing. Is it supposed to be like this? Then we don't have to use this one. Yep, this is the case. Because we are not counting one that we found. Because 4 is always exist, 6 is always exist, right? So we don't have to count this one. So they are like exclusive. All right. Yep, and I really like it that I don't have to go through while loop and calculate the whole thing. Yeah, this one is very exotic one. So you're given zero indexed array nums, where nums is a digit between 0 and 9 inclusive. Okay, The triangular sum of nums is evaluated to present nums after following terminates. Yeah, so for when nums comprise of n elements, if n equal 1, end the process. So we can say if length of nums, how we calculate length. Maybe end the process. Okay, so at the we will be removing from the list, or we will be using pointers. Return sum. Okay, yeah, I understand. Otherwise, create zero indexed array integer. For each index, calculate this, where I assigns the value nums e as yep modulo operation. It's always e plus 1. So how about we will reuse this and we will be reassigning element inside. So okay, yeah. So we calculate lengths, as I said, and then if length equal 1, we return nums 0. This will will know. Okay, for otherwise, how about if we got array, right? We will be calculating this on live array. And we can say nums I equal nums I plus modulus 10. So if we dry run this, this is gonna be 3, and this is gonna be 5. Right here, this is gonna be 5. This is gonna be 7. This is gonna be 9. 5, 7, 9. Okay. Then we move backwards and we calculate this as 8. This will be plus 5 plus 7. Yeah, and in this case, time complexity will be squarish. How much we have? Oh, we in 1000. Let's do squarish. Square complexity. Maybe there is a way to solve it mathematically somehow, but I don't know how to do it. So yeah, let's solve it in brute force way, but without creating additional extra array. So our space complexity will be O1 space and O n square time. Yeah. Okay, let's quickly implement this. for the index value in nums, and we have to calculate edge equal L. So what we're gonna do, we're gonna reassign num_i the whole thing. And here we can say while geo more than 0, and we decrease age, and we return nums1, and this will be nums1, nums0 will contain our answer. Now let's quickly run it. Enumerate, obviously. Enumerate. Yeah, but we cannot go. We are not using this, and we can say range L minus 2. Okay, so it doesn't work anyway. So what is wrong with this? So we have to add edge to the from 0 to edge. Okay, let's print it. Zero, 1, 2, 3, 4. So for h0 we got 0 plus 5, which is 8. This we should get after first iteration. Why not? We are not getting it after first iteration. This is weird. Oh no, we are getting it. So this is 3, 3, 5, 7, 9. 7, 9 is not working. So h -1, I guess. Yes. Now it's working. $75%. Okay, yeah, so this is Pascal triangle. Wait, is this like real thing? Oh, Pascal triangle. Whoa, whoa. Combinations. This is cool. Yeah. This is Pascal triangle calculation. And then we just return sum. Okay, yeah, I have to research it and take a look at it. It's really cool. But yeah, that will be it for today. Thank you for watching. Bye.